Okay, in this video we'll look at this system of equations. Again, we will follow all three methods, like how do you solve this graphing, using the substitution method and the elimination or addition method, however you've learned it. Spoiler alert, this one we will yield no solution. Okay, so let's kind of look at a few things here and why we get no solution. So I always want to solve these algebraically. Okay, a graph, sometimes, it's hard to get the accuracy and sometimes just tedious. It's very time consuming to graph functions and find this point of intersection because that is what we're looking for. So often we want to just do it algebraically. I prefer the method of elimination, but for this one, notice this top equation is already solved for y. So therefore, to solve it using substitution, I would simply plug, right? I'd substitute that 3x plus 2, I'd plug that in for y right here. So algebraically, substitution method on this problem would probably be best. Okay. Stick with black actually. Let's go in and graph these really quick. So the first thing I'd want to see is I prefer graphing when it's in the form y equals mx plus b, like the first one is here, right? Equation 1. Equation 2, though, we don't necessarily have to solve it for y equals mx plus b because I could do this with intercepts fairly quickly. Either way, it's going to pan out. But let's go in and get in slope-intercept form. So I'd add y, so I'd have y minus 3 equals 3x, and then add 3. Right? So y equals 3x plus 3. Now it's in slope-intercept form, y equals mx plus b. Okay, so graphing these, I could see a y-intercept of 2 and 3. Rather than just like drawing an entire graph, I don't know, I think I need a little more of the upper quadrants, just by inspection, but we can always adjust it as needed. Alright, so this first one we'll go ahead and do in a pink. We'll do equation 1 in a pink color. Y equals 3x plus 2, so we'd go up 2. That's our y-intercept. The slope is 3, up 3 over 1. Or down 3, back 1, right? Same thing. Right, there's equation 1. Equation 2 has a y-intercept of 3. And the slope is also 3, up 3 over 1. Or down 3, back 1. Down 3, back 1. Probably could have used an align tool and made this a little more accurate, but that's okay. So where is the point of intersection? Well, again, sometimes on a graph it is a bit challenging to tell, but this one is easy because they have the same slope, right? The rise and run here tells me this will never intersect because as this point goes up 3 and over 1, right to there, so does this point. So if they continuously have that same, up 3 over 1, they will never intersect, right? They're parallel. Two lines with the same slope are parallel. And if they never intersect and they're parallel, then they have no solution. Additionally, if there is no solution, you may see that your homework asks you to classify that. And I'll go and switch to a non-rainbowish color. This is considered inconsistent. Okay, inconsistent and independent. I guess you could think of inconsistent because there's no solution, right? We could not find a consistent solution, and independent because the two lines are independent of each other. I guess that's the easiest way to describe that. Okay, sometimes though, like, I don't want to graph this, too much work. So let's do the substitution method first. So like I said, if you substitute y equals 3x plus 2 into equation 2, so I had equation 2 here, 3x subtract y equals negative 3, and I substitute that y in, right? Then I'd have 3x subtract, I'm gonna write it in parentheses because it's important to note we are subtracting all of y, right? All of 3x plus 2. So distribute that negative, 3x minus 3x minus 2 equals negative 3, and we get negative 2 equals negative 3. Okay, algebraically, sorry, when we don't have a solution, when it's no solution, we'll get some weird random statement like negative 2 equals negative 3. What do we even do with that, right? Doesn't make sense. All right, so last, the elimination method or the addition method. The first thing we want to do, it's easiest to get it in standard form. So if you look at equation 1, I would actually want to subtract that 3x to the other side. Okay, so rewriting it, I would actually have negative 3x plus y equals 2. Right? All I did is I subtracted that 3x to the other side. For equation 2, we have 3x subtract y equals negative 3. We don't need to do anything. Now we try to manipulate these to where something will cancel, but notice if we were just simply to add them as they are, that the negative 3x and 3x cancels, y minus y cancels, and then on the right hand side we have 2 minus 3 is negative 1. So on the left, everything canceled, we had 0. Again, an untrue statement, right? It's not true. It's impossible, which implies there is no solution.